All right, everybody, we are here. Our last assignment, our last video for our balloon car project. Congratulations, you're here. All right, let's go ahead and jump into it. So, we are focusing on our lab write-up today. Over the past couple video assignments, you have decided which Newton's law you wanted to apply towards your balloon car and how that can help your balloon car go faster. You then made those adjustments to your car, and you might have already collected data, or you're going to collect data in this section and use that data to answer the lab write-up questions. Background, we talked about Newton's second and third law, how they apply to forces, mass, acceleration, and how forces can be equal and opposite. Our project objective was to use Newton's laws to redesign our balloon car and make it move faster than it did in experiments 1 and 2. So you have built your improved car. You completed a few trial runs to make sure everything was working. And below are some ideas of things you might want to take notes about. These might help you on your final lab write-up. So are the changes to your car affecting its motion as you thought they would? So is it doing what your intention was? So I wanted it to go faster. Is it going faster? Is it going slower? Is it going straight? Is it going in a weird direction? Okay. Does it appear that you've been able to increase your car's velocity based on those Newton's laws? So this will be a yes and no and why. Which aspects of Newton's laws affect your car's motion? So is it the force, mass, acceleration? Those are kind of your options here. What additional changes can you make to improve your car's performance? Will you need to fix these flaws before continuing your experiment? So, are things to the point where your car's not working, or maybe it's not going as fast as you like? Okay, things like that. You don't have to necessarily fix these flaws, so that's kind of up to you. Procedure for calculating change in position over time. These are your step-by-step how to collect your data if you have not yet. Sorry there. So it's split up into those 3 slides here, and also tells you how to create your position time graph. Okay. You're going to use average time, average position. Use your data table available to you for the position and time. Second part here, change in velocity over time. Couple slides here giving you step-by-step directions, which you should probably be pretty well versed in as we've done it twice before. Your available data table to you here. Also tells you how to create that velocity time graph. Okay. All right, here's the big chunk or the big meat of this assignment. So it's 10 questions. Okay. And I just want to reiterate that a lot of students might answer the question like yes or no. Okay. But you need to explain, to elaborate, provide more details as to why your answer is yes or no. Okay. So number one, restate your hypothesis. So just write out your hypothesis. If this happened, then this happened. And then state whether or not your hypothesis was supported. Say, yes, what I thought was going to happen happened because why? Or no, it didn't happen the way I thought it was, and my hypothesis was not supported because X, Y, and Z. Okay, provide details there. Number two, summarize the motion of your balloon car using the position time graph. So that's the first graph you created. Did it increase, then decrease? Did it not move at all? Okay, what motion of your car happened? Three, how did the average velocity of your car in this experiment compare to the average velocity in experiments 1 and 2? Okay, was the velocity slower? Was it faster? Did it increase, decrease, stay the same? Okay. Four, using your velocity time graph, so the second graph, describe the motion of your car. Was the velocity increasing, decreasing, or staying constant? Explain. Okay, don't forget that part. Explain. Five, consider Newton's second law. Okay, force equals mass times acceleration. If your car had less mass but the same amount of force, how would this affect its acceleration? Okay, if you want to, you can throw a couple numbers in that formula, and that might help you get the answer there. Okay, you're halfway through the lab write-up. That's 1 through 5. Then we have 6 through 10. So 6, considering Newton's third law, what were the action and reaction force pairs that contributed to the motion of your balloon? Okay, how did the balloon get propelled forward? And what force was acting against that forward motion? Number 7, which law did you use to improve your car? Okay, did you use Newton's second law or Newton's third law? And how can the law explain why your car worked better or why it should have worked better? Okay. So sometimes in science, what you think is going to happen might not always happen. Um, but if it was based on a law or based on a detail, you want to explain how it related to what happened. So did the law or excuse did the data follow the law, or did it not in this instance? Tell us. 8, did anything go wrong with your experiment? If so, explain. Describe the steps you took to fix the problem if applicable or if needed. So this can be all sorts of things, like a wheel fell off, my dog chewed up my balloon car. Okay, if something went wrong, explain. Explain what happened and explain how you fixed it. 9. Is there anything you would change in the future about the design of your balloon car? Explain. So, you've been through 3 different trials now. You've changed things, you've practiced, right? You've created graphs, you've done math, and you're probably tired of the balloon car. But if there was a 4th experiment out there, what else would you change? Or would you change nothing? Is it awesome and perfect and super fast? Okay, tell us in number 9. And last but not least, number 10. Imagine you were able to build a balloon car big enough so a person could fit inside. Think of all the materials that would be required. Here's the important part. What would be needed to keep the driver safe in the event of an accident? Okay, that one's kind of expanding. So, in science, a lot of times we do these small experiments to model something bigger. Okay, so if you were maybe not a balloon car, but maybe if your car was powered with something else, and this was a real world scenario, what would you need to keep your driver safe? Okay, that's number 10. All right, 1 through 10. I know it's a little bit more than we've had questions wise in the past few video assignments, but remember this is the last um, part of your project, part of your lab for the balloon car. Congrats to have made it through everything. I'm proud of you guys. So go ahead and chip away at this piece by piece. If you get confused, if you have questions, please let me know. Otherwise, best wishes.